Okay, Wildcats. Today we're looking at Friday, January 19th, square root transformations, and that's going to be on page 45. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. Now, the notes should look fairly familiar. We've done transformations before, and transformations apply to functions the same way. And instead of parentheses here, we have the square root, but it applies just like the parentheses, okay? So we have f of x equals negative a, the square root of negative bx minus h plus k, where the negative outside of the square root in front of a reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative inside of the square root multiplied by the b reflects over the y-axis. When when b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus 8, it translates right. And if it's plus k, it translates up. And if it's minus k, it translates down. So if you would, update your square root transformation notes. All right, now your notes are updated. Let's take a look at the examples. All right, example 1. All right, graph the square root function, describe the transformation, then state the domain or range. Well, in example 1, there is no transformation because it's the parent function. Okay. Now, with the parent function, let's look at the x values. Let's start with 0. So we have 0. The square root of 0 equals, and actually I should write that as square root of 0 equals 0. And then let's try 1. So the square root of 1 is 1. Now we're not going to use 2 because the square root of 2 isn't going to give us an exact whole number, but 4 will work because the square root of 4 is 2. And then we'll go to 9 because the square root of 9 equals 3. Okay? So these will be your directions for all square root functions. Okay? So we graph this. So 0, 0, 1, 1, 4, 2. So 1, 2, 3, 4, 2. And then 5, 6, 7, 8, 9, 1, 2, 3. All right? There's no transformation because it's the parent function. And then domain looks like it's x. Sorry, I forgot. It's bracket 0 to infinity. And it ranges bracket 0 to infinity. All right, now remember, as you're going through the video, if you get stuck on an example, you don't have to go through it. You can wait till class and I'll go over it again with you, okay? But if you continue to understand them, let's keep going. Let's look at example 2. All right, so we graph the vertex first. So the -1 tells us we move to the right 1, and the 2 means we go up 2. So our new vertex is 1, 2. Okay, so then there's HK. Now we're going to graph by direction. So we know 1, 1, 4, 2, 9, 3. But you have to incorporate the -3. So we actually have to multiply the y values by -3. So that's 1 times -3, 2 times -3, and 3 times -3. So our new y direction is -3, -6, and -9. So from here we go to the right 1, down 1, 2, 3. To to the right 4, 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6, and to the right 5, 6, 7, 8, 9, down 1, 2, 3, 4, 5, 6, 7, 8, 9. So the transformations. So the 3 on the outside is greater than 1, so we know it's a vertical stretch of 3. The negative on the outside tells us it reflects the x-axis. The -1 here tells we go to the right one. And the +2 means we go up 2 units. All right, domain looks like it's bracket 1 to infinity. And the range is negative infinity to bracket 2. All right, so go ahead and finish up example 2. All right, example 3. Use the description to write the square root function g based on the parent function f of x equals square root of x. So basically, what you're going to do is you're going to write the square root and incorporate the transformations here. Now, this has all of them, and it might have 1 or 2 or 3, but it probably won't have all of them. But that's what you're going to do. So we know it's f of x equals. So it says reflects across the x-axis. So we know that there's a negative on the outside. It says it compresses vertically by a factor of 1/5, so there's a 1/5 on the outside of the square root. Now, it doesn't look like there's any left or right transformation, so it's the square root of x. Down 4 means -4. All right, at this point, I would probably try to do example 4 and 5 on your own. And then once you have that, then continue the video. All right. I assume that gave you some time to do example 4. So now and 5. So let's take a look. So it's f of x equals, so it reflects f across the y-axis. That means the negatives inside of the square root. And then translates up, so there's a +3 outside. All right, example 5. So f of x equals, so it translates left 5 units. So left 5 units means it's x plus 5 inside the square root. And then down 4 units, so -4. All right, so go ahead and finish up example 3 through 5. And remember, if you have any questions on them, I'm more than willing to go over any and all the examples in class again. All right, example 6 and 7. It says graph the square root inequality using transformations. So it says y is greater than square root of x plus 4. So we move the vertex, so then we know +4 means we go left 4 units, so 1, 2, 3, 4. And then we're going to graph by direction. So 1, 1, 4, 2, 9, 3. So we go to the right 1, up 1. To the right 4, 1, 2, 3, 4, up 2. And then to the right 5, 6, 7, 8, 9, up 1, 2, 3. There's no line underneath, so it's a dashed line. Now, before we do shading, something you have to think about is -4 plus 4 is 0, and that's this point right here. But -5 plus 4 is a -1, meaning that's an imaginary number, so you can't graph that. So none of your points can go further left than 4. Okay, so while you're shading above, because it's greater than, you can't shade anything to the left of 4, because that would be an imaginary number. All right, so let's look at example 7. So it says y is less than or equal to negative square root of x plus 3. So it looks like we move the vertex up 3, so 1, 2, 3. So again, we're graphing by direction, so h and k. So we know 1, 1, 4, 2, 9, 3. But you have to multiply the y values by -1, so times -1. So that's -1, -2, -3. So we go to the right 1, down 1, to the right 1, 2, 3, 4, down 2, and to the right 5, 6, 7, 8, 9, down 1, 2, 3. There's a line underneath, so it's a solid line. Now, the square root of 0 is 0, but the square root of -1 is an imaginary number, so you can't go further left than x equals 0. Since it's less than, we shade below. All right, so at this point, you have two options. Option 1 would be that you had some questions on examples, wait to class, we go over them. Option 2, you understood the examples, and I would start working on the assignment before you come to class. So as always, have a wonderful Wildcat day.